Alrighty. This will be our first problem for chapter 2. So at this point, I probably pause and rewrite the question. All right, so the horizontal velocity of Bruce's fastball pitch is 40 meters per second at the instant it's released from his hand. If the horizontal distance from Bruce's hand to home plate is 17.5 meters, how much time does the batter have to react? So, this one. So, they gave us a velocity of 40 meters per second. They gave us the distance, 17.5 meters, and we're looking for time. So, one of the basic equations that shows the relationship between velocity, distance, and time. So velocity is distance over time. So they gave us velocity, they gave us distance. 17.5 over time. Do some rearranging. Solve 0.375 seconds. And that is the first problem. All right, so this will be our second question. And it has a total of whatever A through F is, quite a few parts. So Jerry is leaving the long jump takeoff board with a vertical velocity of 2.8 meters per second and a horizontal velocity of 7.7 meters per second. So part A, we want to know her resultant velocity at takeoff and what the takeoff angle is. So let's draw that. So we've got horizontal velocity of 7.7 meters per second. We have vertical velocity 2.8 meters per second. So we want to know what's that, and also what's that. So to get x, we'll Pythagorean theorem. It's also the same for your chapter 1 problem 1 practice. It's the exact same concept. So 2.8, 2.7, c squared, 8.2 meters per second. And now for theta, so tangent opposite over adjacent, opposite over adjacent. So theta is going to be 9.98 degrees, which is about 20. So that's part A. So part B, we want to know her horizontal velocity before she lands. So page. So they gave us the initial, horizontal as 7.7 meters per second. So they want to give us the final x, or in the horizontal. So assuming for this problem, there is no, or rather, horizontal acceleration is constant, as in it's 0. So our initial is going to be the exact same as our final. So v of x is going to be 7.7 meters per second. That's part B. So part C, so she's in the air for 0.71 seconds. So what is the horizontal displacement during this time? So part C. So they gave us a time. And said find delta d sub x. So using one of those fun equations, we have this. So we already know what that is. So now we just plug and chug. And that is part C. Moving on to part D. So we now want to know her vertical velocity at this time. So what is v sub y when t equals 0.71 seconds? So for this problem, it's assumed that you know the acceleration for gravity. It's 9.81 meters per second squared. So for this problem, our gravity is also the same as our vertical acceleration. So using one of those fun equations you have, you get something that looks like this. So VI is V initial, which they gave us. We're looking for V final. We have gravity, and we have time. So at this point, it's just plugging everything in. So 2.8 meters per second plus negative 9.81 meters per second squared times 0.71 seconds. Plug in a calculator. So from that calculation, you should get 1651 meters per second. So what the negative is telling us is that she's moving downwards at 4.1651 meters per second. And that does it for part D. So part E, it tells us her center of gravity was 1.0 meters high at takeoff. So how high will it be at the peak of her flight? So looks something like this. When she lands. So here at the peak, we're looking for that distance. So let's list all the variables we know, either given or implied. We got gravity. So d sub y is what we're looking for. Or rather, so delta d sub y is final minus d initial. So they gave us d initial. We're looking for d final. So we also know our vertical acceleration, or not vertical acceleration, vertical velocity initially is 2.8 meters per second. And then we know our total time, 0.71 seconds. So for this one, we don't want total time. We actually only want time at the peak, which time at the peak is half of total time. So the t we're going to use is 0.355 seconds. I'm going to look that up. So then using a handy dandy equation we have, so d sub y final is d sub y initial plus initial vertical velocity times delta t plus 1/2 g delta t squared. So just another plug and chug. So they gave us that. That's 1 meter. We know that from previous problems. 1.8. That's the time we're going to use. 0.355 plus, I ran out of room, so we're going to go down here. 1/2 -9.81 meters per second squared times 0.355 squared. So plug it into your calculator. So our DUI final would be 10.32 meters. And that does it for part E. Correction, I mistyped in my calculator. Actually, 1.3758 meters, which is around 1.4 meters. So that does it for part E. Lastly, this brings us to part F. So how high is her center of gravity when she first hits the pit? So exact same math we just did on part E, but instead of using that half time, we're just going to use time. So we've got d sub y final equals d sub y initial plus vertical initial delta t is 1/2 gravity delta t squared. Still looking for this. Still 1. Still 2.8. But now our time is 0.71. 1/2 -9.81. 0.71 squared. So plug all that in your calculator. So her center of gravity is going to be 0.5153 meters high, or around 0.52 meters. And that does it for your chapter 2 problems.